Alright. It tried to trick me again. Like, I didn't know when it was recording. Got it this time. Boom. Alright, continuing on. My battery's gonna die at any time. So if it dies during this video, that kinda blows. But then I'll just continue my last one. Whoa. Here we go. So we stopped last time at 5. Let's pick up number 6. We're still talking about the Algebra Regents 2013 coming at you. 2013 coming right at you. Let's start at number 6 and see what we got. Alright. Given, right? They gave us something. Here we go. Am I? Yeah, we're good to go. Given A are all odd integers from 1 through 19 inclusive. This is a little confusing word, so we're going to have to bang into that. Inclusive. I just want you to... That's the second time you got me with that. Inclusive. We're going to talk about what inclusive is. And B is 9, 11, 13, 15, 17. They want to know a complement of set B that is within set A. Alright, here we go. A lot of terms being thrown at you. A lot of terms. Hopefully you know what they mean. Because the Algebra Regents, the Algebra people, they want you to know. They want you to know what it means. Here we go. Inclusive. First word of the day. Inclusive means that we are going to include the endpoints of the two things, right? So what this is saying is they are saying that set A are all the odd integers from 1 through 19. Hey, what's up? Now I got a phone call. Nobody wants me to make this video. Nobody wants me to make this video. They say it's helping people too much, so here we go. Inclusive. That's what I was saying. It means that it does all odd integers from 1 through 19, including 1 and 19. Okay, so what a set is, and we can know this is set because when they're like when I look like that. So when it's included in brackets like this, these little squiggly things, those things that took me like years to learn how to draw. When it's in that, we call that a set. And all a set is just a group of numbers or terms or ideas or items or atoms or anything. A set is just a group of them. And the difference of a set and these huge or number lines and stuff is that a set is confined to just the numbers in there. So in this set right here, we don't care about 9.2, or we don't care about 10, or we don't care about 12. All we care about are the actual numbers in the set. So in a way, it's easier when we see sets because all we have to do is deal with the numbers that are in there. So in set A, they are saying we have all odd integers. Okay? So we forgot to talk about this. An integer. An integer is just numbers like 9, 11, 13, 15, 17. You can look up what integers are. But it has to be an integer. And it has to include 1, it has to include 19, that's what inclusive is. So let's just list A, kind of, if you don't mind. So A is going to be 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. Look at that, perfect. See how it fits in? You would swear I do this stuff on purpose, but it just works out. I said B. This dang program keep freezing while I'm writing. B is 9, 11, 13, okay, 13, 15, and 17. Right? We're gonna mute this phone because You know, they will just continuously call. And 17. Right, so there we go. We have our 2. So we're looking for 2 things here. We're looking for the complement of B. We talk about what a complement is. And we're looking for not just the complement, but the complement of set B that is within set A. Okay, so here we go. Complement, or sometimes you can see a complement as a prime symbol. So the complement of B would be written as like this. B prime means complement of B. Okay. That means all the numbers that are not in B. So that's a huge set, right? That's a huge set. That's every single thing that's not in B. So that's an infinite set, right? That goes on forever. And A is this. So we're looking for a complement of B that is within A. So pretty much everything in A that's not in B. You know what I mean? So let's cancel them out. We know 9 is in both. So it can't be 9. We know 11 is in both. Can't be 11. We know 13 is in both. We know 15 is in both. We know 17 is in both. So really all we have left is 1, 3, 5, 7, and 19. 1, 3, 5, 7, and 19. Boom, shakalaka. That problem was pretty cool because you learned a little bit about sets. So that's what sets are. Inclusive means that we're including the n numbers, or we're including whatever they say inclusive of. Complement is all the numbers or all the items that are not in set whatever. In this case, set B. And here, it's within set A, so it has to be within the first set. Cool stuff. Let us move on to number 7. Which equation represents a line that is parallel to the line whose equation is this? Another fantastic question that you know 101%, I guess this time, that is going to be on the Regents. It's going to be on the Regents. So learn how to do this. I'm going to do it with you, but that does not mean that you understand it. So practice these on your own because they love this. And, you know, rightly so. I mean, you know, it helps you think. And you'll probably see this later on if you want to do math. You'll definitely see this in Algebra 2, and you'll definitely see these in geometry. Probably even pre-calculus, definitely calculus. So it's going to be everywhere. So learn how to do it because it makes your life a lot easier. Learn from my mistakes because I didn't know how to do these, guys. Line parallel to a line. Who's this? So what's the first step? You see how my battery's dying? You thought I lied to you, didn't you? I got 14% left. So why get out of here? Here we go. Alright. Parallel lines. What the heck are parallel lines? Parallel lines are 2 lines that have the same... Let's see if you remember. I'm not going to tell you right away. I'm going to make you work for it a little bit. Think about if you remember what it is, as my computer keeps freaking freezing. Parallel lines. Oh my gosh, you gotta be kidding me. Parallel lines have the same... This is a joke. Never again. Sorry guys. In my next program, I will not be using this program. What's the program? You know what? I'm gonna blow them up. I will not be using Blueberry video recorder. Because look at this. The thing keeps freezing. I don't understand. They can't even make a good program to record. Parallel lines equals the same slope. Okay? So we know that in our line, in our new equation, we're going to be looking for a line with a slope of -3. Alright, so already we know we can cancel out this one because that slope is minus 1/3, and we can cancel out this one because that slope is 1/3. We know it's got to be that. Also, it's got to be minus 3. So this one, look at this, that's positive 3. So we already know that our answer has to be this. Okay, we are done. Oh, that's the entire question. I thought they were going to ask us more. I thought they were going to give us a point. So there you go. That's all we got to do. All I do is see that if you understand that parallel lines have the same slope. Pretty easy, huh? Further thoughts about these? I don't think so. I think we're okay with it. Questions on it, obviously leave it in my comments. Let us see what else we have here. Watch this. Moving on. Layer 4. Boop. And freaking, I'm getting good at this. See that blowing up my phone again? But I got it on vibrate, so it doesn't interrupt you guys. Number 8. Which graph does not represent the function, or does not represent the graph of the function? Of a function. There you go, that makes more sense. Alright, so we need to understand what a function is here. Right? We need to know what a function is. I like this color purple. A function, oh god, they get me every time. Oh, now we're good. A function, oh jeez, this is really annoying. Means that for, or I'm just gonna write it here, it has to have a 1-to-1 relationship. Okay, so what the heck does that mean? That means that for every x value, there needs to be 1. And only 1 corresponding y value. Let me give you an example of what is not a function. In this question, we have this point right here. We will call this when x equals 1. However, if we look at the y values for when x equals 1, we see that it corresponds to this point, but that's not it. It also corresponds to this point. You see that? So that means that this cannot be a function, because a single x value, the single x value of 1, corresponds to both this point and this point. So number 3 cannot be a function. So we are looking for something. We are looking for what does not represent a function. Oh, darn it. So number 3 looks like it could work, can it? So I just gave you the answer. Darn. Dang. So, look at this. We gotta do this quick. So we know that that's what functions are not. They can't hit it. So in this question, or in this function, or in this graph, every x point that we pick, if you draw vertical lines, they're only touching one spot, right? They're only touching one spot. So that is a function. That is a function. In this case, no matter what you pick, no matter where you are, it's corresponding to one x value. If anyone has any good ideas of screen or like video recording programs, please advise me, because I feel like I can't get a good one. It should be free at least. I don't want to really spend money to record my screen. I mean, come on. So if you have any suggestions, please leave it in my comments, because I can't. This is really annoying. It's frustrating. And the better experience for me, and maybe a better experience for you too, because you don't have to deal with me constantly getting to the point of throwing my computer. And the last one's here, and I'm going to show you. We use something called the vertical line test. That's what we've been doing. Vertical, oh goodness gracious, line test. Right? And all that means is that if we drop a vertical line anywhere on this graph, it should only touch one point on the graph. Bam, bam, bam. It's only touching one point. If something passes the vertical line test, if it passes the VLT, then it is a function. So really, that's what it comes down to. If you're testing a function from a graph, all it comes down to is if you can pass a vertical line test. If you pass the vertical line test, it's a function, because every point on the graph, it's corresponding to 1. Just 1, not 2, but 1, not 3, but 1 y value. You see that? However, here, in this function, or in this non-function, no matter where we drop a vertical line, it is not touching 1, it is touching 2 points. Right? It's touching 2 points. That is why it is not a function. So if something fails the vertical line test, it's not a function. Oh, it's freezing on me! It's freezing on me! It's not a function. It's not a function. Not a function. You know, I usually use another program that doesn't freeze, but I figured you guys wanted to see my face. So, that's why I use this one. But I would like another program that I can also show my face on. I think it helps you guys when you can see me talking. I wanted to do number 9, but my computer's gonna die in like 30 seconds, so we'll do 9 next time. I hope you guys enjoyed what you saw here. And if anybody can recommend like a free screen recording program where I can record my face as well, can you please suggest it to me on the comment section? I will greatly appreciate it. It will help me, help you do well on your Algebra Regents, and get into that college that you really want to get into.